All right, strap in everyone, because today we are tackling a real cosmic brain twister.
Oh, I love a good cosmic brain twister.
You know how we always hear that the universe is like 13.8 billion years old?
Right, that's the age that's generally accepted based on all the measurements we have.
Okay, so then how can we see things that are way farther away,
Farther. Like how far?
like 46 billion light years away?
Wow. Okay, that's a lot further.
Yeah, it just doesn't add up. It's like saying you ran a marathon in under 3 hours, but your watch says you ran like 80 miles.
It does seem like a paradox, right? Because our intuition tells us that if the universe has only been around for 13.8 billion years, then that's the farthest we should be able to see.
Yeah, exactly. Because light takes time to travel.
It does, but the universe has a few tricks up its sleeve.
All right, so where do we even start to untangle this? Is it like a trick of the light? Or what?
It's more profound than that. We need to kind of shift our thinking about space and time. Think of it this way. The universe isn't like this static box with things just neatly arranged inside.
Yeah.
It's more like this dynamic, ever-changing fabric that's constantly expanding.
Okay, so it's not just the stuff in the universe moving, but the universe itself is stretching.
Yeah.
That's where Einstein comes in, right?
Yes, exactly.
With this whole space-time thing.
Exactly. Einstein's theory of general relativity, it totally revolutionized the way we understand gravity. You see, he showed us that mass and energy can warp the fabric of space-time.
Okay.
It's kind of like how a bowling ball would create a dip in a trampoline.
Okay, so I'm picturing this giant cosmic trampoline.
Yeah.
And the galaxies are like marble sprinkled all over it.
I like that, yeah.
So the heavier the marble, the bigger the dip it makes.
You got it. And here's where it gets really, really interesting. Imagine that the trampoline itself is expanding outward while the marbles are making their little dips.
Oh.
So that's essentially what's happening in the universe. The space itself is stretching and it's carrying the galaxies along with it.
Wait, so it's not that the galaxies are like flying away from each other through space, it's that the space between them is growing.
Yes, you got it. It's a really subtle difference, but it's so important.
Okay.
And the further away a galaxy is, the more space there is to stretch, and so the faster it seems to be moving away from us.
Okay, that makes sense. So that explains why we see some galaxies zooming away faster than others, but how does that let us see something 46 billion light years away when the universe is only 13.8 billion years old?
Okay, so imagine a beam of light leaving a distant galaxy 13.8 billion years ago, right at the beginning of the universe.
Okay.
Right, so that light starts traveling toward us. But remember, the universe is expanding.
Right.
So as that light is traveling, the distance it needs to cover keeps increasing. Does that make sense?
Yeah, so it's like trying to walk up a down escalator. You're moving, but the ground beneath you is also moving, so it makes the trip longer.
Perfect analogy. So by the time that light finally gets to us after traveling for 13.8 billion years, the galaxy that sent it has been carried much further away by the expansion of the universe. And that's how we end up seeing objects that are now 46 billion light years away, even though the light itself has only been traveling for 13.8 billion years. It's like the combined effect of the light's travel time plus the universe's expansion.
So it's kind of like the universe's expansion has given us a cheat code.
Yeah.
It lets us see much farther back in time than we normally would be able to.
Precisely. It's like having a time machine. It lets us peek into the universe's distant past. We can see those ancient galaxies as they were billions of years ago, just bathed in the light that started its journey when the universe was young.
That's incredible.
It is amazing. And that's how we get to this mind-blowing idea of the observable universe.
Okay.
It's like a sphere with a radius of 46 billion light years.
Whoa. Okay, so even though the universe is only 13.8 billion years old, the part we can actually see is 46 billion light years in every direction.
It is, yeah. It puts things in perspective, doesn't it? And here's something even crazier. We're only seeing a snapshot of the universe as it was billions of years ago.
What do you mean?
The light from even more distant objects, it hasn't reached us yet.
So there's even more out there beyond what we can see.
Yeah.
That's both exciting and kind of freaky.
Absolutely. It's like standing at the edge of this unexplored ocean, There's a whole world hidden beneath the waves.
I like that analogy.
Uh-huh.
So speaking of unexplored territory, we got a bunch of questions from listeners.
I bet.
They're all super fascinated by this, cosmic puzzle we're talking about.
The good one.
This one stood out to me. It says, if the universe keeps expanding, will we eventually lose sight of those distant galaxies?
Oh, that's a great question. And the answer is yeah, unfortunately. As the universe keeps expanding, that light from those distant galaxies is going to get stretched out more and more. Eventually, it'll be redshifted so much that we just won't be able to see it with our telescopes.
So it's like they'll fade away into the cosmic background.
Pretty much, yeah. It's kind of sad in a way, but it makes our current view even more precious, right?
How so?
Well, we live at a time when we can actually see these ancient galaxies, and they can tell us so much about the early universe, future generations. They might not have that opportunity.
That makes our work, mapping and studying the universe even more important.
Exactly. We're capturing this unique moment in time, this cosmic snapshot.
Okay, here's another question from a listener. This one's a good one. It asks, does everything in the universe expand? Like, are atoms and planets getting bigger too?
That's a question we get a lot, a common misconception. It's important to remember that this expansion we're talking about, it mainly affects things on a really large scale, like the distances between galaxies.
Okay, so it's not like everything is inflating like a balloon.
Exactly. Think about it like this. Imagine you have a loaf of raisin bread dough, and it's rising in the oven.
Okay, I'm picturing it.
The raisins, those are like the galaxies. They're moving apart as the dough expands, but the raisins themselves, they stay the same size. So the space between galaxies is stretching, but the galaxies themselves and everything inside them, they're held together by other forces.
Like gravity.
Like gravity, yeah, exactly. Gravity is what keeps our solar system together, and the electromagnetic force, that's what holds atoms together.
Okay.
And those forces, they're much stronger than the expansion of the universe on the smaller scales.
So it's like a cosmic tug of war.
Yeah, I like that. Expansion is winning on the big scale, between galaxies, but gravity and these other forces, they keep things together locally.
Wow, okay. That's a lot to think about.
Uh-huh.
So we've covered a ton of ground today, right? We've talked about the crazy size of the observable universe, the delicate forces that are, governing its expansion. But before we wrap things up, there's one more piece of this puzzle that I think we should explore.
Oh, what's that?
Well, it's a question that's been around for a long time.
Ah,
It's as profound as it is perplexing.
you've got me intrigued. Let's hear it.
Okay, so if the universe is expanding, what is it expanding into?
Ah, yes. The classic question.
Hmm.
It's one that can really make you think.
It's a tough one. And it leads to even more fascinating questions about the nature of space and time.
Absolutely. Stay tuned, folks, because we're about to dive into that in our final segment.
Okay, so we've been talking about how the universe is expanding, right?
Yeah.
And how that lets us see objects that are way farther away than we'd think possible. But this leads to a really fundamental question.
Yeah, a question that has puzzled people for, forever.
Right. If the universe is expanding, what is it expanding into?
That's the big one, isn't it?
It is. It's like when you blow up a balloon, you can see it getting bigger inside the room. It's pushing out against the air. But what about the universe? What's it pushing against?
You see, that's where our normal way of thinking about things, it kind of breaks down.
What do you mean?
Well, we're used to thinking of space as this container and everything is inside it.
Right.
But when we're talking about the universe itself, that idea, well, it might not work anymore.
So you're saying the universe isn't expanding into anything, it's just making more space as it goes. Yeah, that's basically it. That's what Einstein's theory of general relativity tells us. The universe isn't expanding into some pre-existing empty space. It's more like the fabric of space-time itself is stretching and creating more space.
Okay, so it's not like a balloon that's inflating inside a room.
Right.
It's more like the balloon is everything and it's just creating more balloon as it expands.
Exactly. The universe, it's not expanding into something, it's the fabric of space-time itself that's stretching.
I think I'm starting to get it. But doesn't that mean there's an edge to the universe? Like if you kept traveling out in one direction, wouldn't you hit a boundary? Like where space-time just stops?
Ah, now that's a really tricky question. We don't actually know for sure if the universe has an edge. It could be that it's finite but unbounded.
Finite but unbounded. I don't get it.
Okay, think of it like the surface of a sphere.
Okay.
You can travel around on a sphere forever, right?
Yeah.
You never hit an edge, but it's still finite. It has a limited area.
So you're saying the universe could be like that?
Exactly. And we know that mass and energy can warp space-time, so it's possible that the universe itself as a whole is curved in some way.
Whoa. So the universe might be finite, but without a boundary.
Yeah.
And it might be curved.
It's mind-blowing, isn't it?
It is. My brain is doing backflips right now.
Yeah.
So much for our simple question about how we can see those distant galaxies.
I know, right? It all started so simply.
But that's the beauty of science, isn't it? One question leads to another, and suddenly you're exploring the very fabric of reality.
I love it. It's what keeps me going.
Me too. So to wrap things up, we've learned that the universe is much more than meets the eye. It's vast, it's expanding, and it's full of mysteries that we're only beginning to unravel.
Exactly. And the more we learn, the more we realize how much more there is to discover.
That's a great note to end on. So to all our listeners out there, keep asking those big questions, keep looking up at the night sky, and never stop exploring the wonders of the universe. We'll see you next time.